slowly kick off this event. So once again, good morning, everyone. Welcome to this joint SIG-GIA and 5G ACIA webinar. My name is Kostas Trichias. I'm with the SIG-GIA. I also have the pleasure of serving as the chairman of the technology board of the SNS COOP. And I'm pleased to welcome you to this joint webinar on updates regarding recent 5G and 6G achievements from the SIG-GIA and 5G ACIA, of course, focusing on industry and manufacturing trials and pilots. We have a full, very interesting event today. Let's just very quickly go over some guidelines that will hopefully make a pleasurable event for all of us. Do keep in mind that the event is being recorded, and the recording will become available after the event on the registration page, the same page that you used to register. We foresee that we'll have quite a few people today, so please keep your microphones muted at all times if you're not presenting. And feel free to use the chat box to ask questions to the presenters. We'll do our best to try and answer them throughout the event. And as I mentioned, the recording and the slides that you will see today will become available after the event. So we hope you're going to enjoy this event and find it useful. This is the agenda of what we'll be discussing today. We'll start with a quick welcome message from Dr. Colin Wilcock, the SIG-GIA board chairman, and of course, Dr. Andreas Müller, the 5G ACIA general chair. We'll move on to discuss some trials and pilots activities from the SIG-GIA side, including some past achievements from the 5G PPP. And we'll have, again, some discussion regarding relevant trials and pilots from 5G ACA side. And then we'll be discussing with some champions from ongoing projects that are addressing industry and manufacturing use cases from both SNS JU side and the 5G ACIA. We'll have then a very interesting panel where we'll discuss about lessons learned and key takeaways from all our past experience regarding these use cases. And of course, we'll discuss what's coming next regarding trials and pilots on industry and manufacturing. So we hope that you'll find this event very interesting. Why don't we kick things off with the welcoming message from Colin Wilcock, the chairman of the SIG-GIA board. Colin.
Thank you, Kostas, and good morning, everyone. Yes, on behalf of the SIG-GIA, I would like to welcome you to this event. I think it's really important because the whole hope of 5G and indeed 6G is to move beyond the classical telecoms and try to bring in other domains, not just for the benefit of the telecoms industries, but also to digitize other industries. And I think Industry 4.0 or industry in general is clearly one of the strongest areas where it could really make a difference. But we've learned that this isn't easy. This requires a lot of collaboration, a lot of discussion, and a lot of trials and work together to find the right solution for today and also for tomorrow. And I see this event very much as a continuation of the first meeting in Nuremberg, where it was discussed how to move forward. And I hope this will then be a regular event where we can bring both communities together and really find the best solution for both communities in terms of technology to make sure we can digitize and bring advantage. And with that, I'll hand back to Kostas.
Thanks so much, Colin, and thank you for being here. And let me give the floor to the general chair of the 5G ACA, Andreas Müller. Andreas, please.
Yeah, thank you very much, Kostas, and good morning, everybody. Big pleasure to be here today and that we can have this event. Also on behalf of 5G ACIA, of course, I would like to welcome everybody. As Colin said, right, this is all about collaboration. So we have to bring different worlds together. The ICT industry, of course, very much represented also by SIG-GIA. But then if you look at different verticals, and manufacturing certainly remains one of the top verticals to be considered. So then it's also organizations like 5G ACIA. So that's why it's very good to have this joint meeting today. We have had quite a long-lasting collaboration with 6GIA and before even 5GIA. Maybe there was not always so many activities, but now it's an important step maybe to change this a little bit. And I'm very happy, especially about today's theme on tests and pilots and trials, because this is what really is needed, right? So we should not just talk about it, not just think about use cases on PowerPoint slides or shape standardization. At the end of the day, especially in the OT industry, you want to see things live. You want to see it in real world environments. And for that, trials and pilots are super important. So that's why I'm personally very much looking forward to see what has been going on in 6GIA. I know it very well for 5G but I hope that it's very informative and interesting for all of you, and that this is an important next step then in making the industrial 5G vision become a reality. So thanks a lot, and back to you, Kostas.
Thank you so much, Andreas, and many thanks to you and your colleagues for enabling this joint event. So with that, let's dive into the content. In the next, let's say, 10 or 12 minutes, I'll do my best together with two key colleagues from the CGIA to give some information regarding some highlights from the SNS side and CGIA side on trials and pilots. So we have with us Didier Boers from Nokia, who's also the core team chairman of the trials and pilots brochure activity. He's been leading this activity for many, many years now, so he's very experienced and very well positioned to explain what's been happening there. And we also have Carlos Anton Haro with us, who's the chairman of the CGIA Trials Working Group. So indeed, they're both very knowledgeable regarding the trials and pilots activities in the CGIA and SNSJU side. So together, we're going to discuss three major highlights from the 5G PPP and 6GIA side. I'll make a start, and then my colleagues will take over. What I would like to go over with you is the vertical engagement tracker, which is one of the most critical tools that we have developed from the SNSJU side in terms of keeping track of the trials and pilots taking place in the SNSJU projects, the verticals they address, the stakeholders, the use cases, etc. So this is a publicly available tool through the SNS website. It's an interactive platform mapping and monitoring the use cases developed under the SNSJU program. And it covers several industry domains, of course, industry and manufacturing included. Here's some key data regarding this tool. It currently contains 283 use cases mapped from data from Call 1 and Call 2 projects, including some third-party experimenters from some open calls that the SNSJU projects are running. 237 of them belong to 11 key vertical sectors that the SNSJU projects are really focusing on, while we have 46 additional use cases addressing other verticals. There's 59 projects mapped from Open Calls 1 and Open Call 2. There's more than 25 locations around Europe covered within this data, and 6 different experimentation types and methods. So we go from simulation up to trials and pilots reaching a tier level of 7. So there's different functionalities mapped, different verticals, and there's also a link to the related vertical associations for anybody interested to follow up some more. So for instance, industry and manufacturing use cases are always linked back to activities from 5G, ACIA, etc. The very interesting feature about this tool is that it's completely interactive. There is a lot of filtering possibilities. You can filter by call, by industry, by experiment type, by country or functionality. So it really is suitable for giving you a very good picture of what's going on which sector, where in Europe, by which project. So there is a functionality for embedded automatic charts with dynamic filtering options. Just to get an idea of the initial layout, this is what it looks like. There are, as you can see on the left-hand side of the picture, multiple filtering options, and on the boxes on the right, you see individual use cases by different projects and the vertical sector they include. There you can click on them, and then you automatically get a detailed use case description regarding the relevant project, the use case, and the vertical association link. And you will see that on the bottom left, there is this vertical cartography interactive charts button, which will drive you to the interactive charts session. And then you can create charts like this on the go. For instance, this provides an overview of the different vertical sectors from call 1 and call 2. You can see some of the numbers covered. You can filter by call, or you can filter by vertical industry. And another example would be, for instance, filtering by type of experimentation, starting from demonstration, trial, proof of concept, simulation, prototype, or pilot. You can create multiple such graphs. I only provide a couple of examples here to indicate how this could work. And I guess my main message here would be to please go check this out. It's definitely a very good way to enter into the world of experimentation under the SNS COOP, find out a lot more about what's happening and which sectors are being addressed. And then from there, you can follow up in the relevant projects or associations. We consider this a very useful tool, and we invite all of you to start using it and create your own charts based on the data. Just keep in mind that we will very soon start the process to also include data from the recent projects that started in 2025 from Call 3 projects. So this is a tool that's being continuously updated. And with that, I'm going to close the tour, let's say, of a vertical engagement tracker and hand over to my good colleague Didier Bourse to take you over the trials and pilots brochure.
Yeah, thanks a lot, Kostas, and thanks to all of you for joining and attending. So indeed, we have developed during the 5G infrastructure public-private partnership this brochure on trials and pilots. So we have, let's say, step-by-step thought about looking at the number of trials and pilots that were organized, selecting and highlighting top 10 of the different trials and pilots, thanks Kostas, that were happening step-by-step in the 90+ projects of the PPP, in fact. So we define an overall process with call for inputs, and then with panel of experts selecting the different input received. And then we decided to release step by step, let's say, 4 consecutive brochures in September 2019, December 20, August 21, and November 23. So it's very good also inputs to be, let's say, in order to better understand what has been done in the PPP, to be also review. Each time you have a 2-page flyer explaining the trial and pilot for the different selected projects. So in total, 40 trials and pilots that have been highlighted. So I thank also again all the inputs, all the champions for the input, and also the panel members who were contributing to the evaluation and selection of these trials and pilots. If you can go to the next slide, please, Kostas. Then we decided at the end of the PPP to wrap up and to sum up, to release, and this was a huge work, to release a summary brochure. So a summary brochure identifying all the trials and pilots that have been achieved during the lifetime of the PPP. Again, 90+ projects. PPP was 93 projects in total, including the coordination support action. And looking at, let's say, 322 trials and pilots that are reference for the complete lifetime of the PPP. In this summary brochure, you see, let's say, the key fact and how it was distributed over countries, as highlighted by Kostas, plus also the different areas covered. If you go to the next slide, just as an illustration of what you can find in the brochure is across the different calls of the PPP, there were specific strategic objectives, specific calls that were dedicated to vertical in the different phases of the PPP, and you see how it was distributed, let's say, during the lifetime. And you see on the right the cities where trials and pilots were organized. So clearly, as you can see on the map, very well distributed over Europe. If you go on the next slide, please. Then you see we also analyze on this 322 trials and pilots how the distribution was done across the different vertical and the different phases. So you see for the phase 2, 3.1, 3.2, and again, it's obvious, industry 4.0, manufacturing was clearly on top of the trials and pilots for the PPP. If you go on the next slide, please. And then you see just an example of what you find in this nice brochure, just highlight just example, for instance, the 5 growth project or 5G smart project or 5G induce, the way it is presented in the summary brochure. So basically, you see the name of the trial and pilot, you see the date, you see the location, and then you see the vertical that was addressed. In this case, you see Industry 4.0. So I clearly encourage you. It's really a very good entry point also to better understand what has been done in the different sectors, including industry and manufacturing. If you go on the next slide, please. Yeah. Thanks, Costa. So this is just to highlight also what we are converging now before EU CNC and 6G Summit 2025. So happening at the beginning of June, several of you will be in Poznan. And you see, so we have selected 8. We start very early for the SNS, the project. So we have just 2.5 years after the start of the SNS in terms of contractual project. So you see we have 8 selected trial and pilots, and I highlighted here on this slide for Imagine Me 5G, for Target X and TrialsNet. We will have specific dedicated presentation of the project, and we will have also contribution to the panel for TrialsNet in the session this morning. So that's it from my side. I pass the hand to Carlos. Thanks to all of you. Thanks.
Thank you so much, Didier. And Carlos, please, the floor is yours regarding Trials Working Group.
All right, many thanks. So yes, this is an attempt to describe in just 3 minutes what the Trials Working Group is about. Next, please. Here's a selection of the objectives as per the terms of reference, which are, as you can see, it's designing or developing a 6G European trial roadmap in relation with SNS partnership activities. It's also a priority to facilitate involvement of verticals in this roadmap, because they are the final users of this technology. It's not only about technical discussions, but also business principles are discussed in the Trials Working Group activities, and coordination with initiatives at the international level that is beyond the EU is also considered as part of its mission. What else? It's also key to favor the dissemination of the work carried out with verticals, as done by the European projects under the SNS umbrella, in such a way that it also serves an input for the definition of the strategic future releases of the SRIA and also the SNS R&I work programs. And more on the technology transfer side, there's also a goal to facilitate the transfer of the solutions being developed in trials and pilots towards the market, leveraging on digital innovation. So next, please. This is the way that the activity of the working group is organized in a number of streams or sub-working groups. One, you can see the responsible people there, one on private trials and liaison with the observatory, one more on use cases for city verticals, one dedicated to trials and city vertical, led by Jorge Husco from VTT, international cooperation, as I already said, with other regions of the world, and also interaction with digital innovation hubs. The working group is chaired by myself, and all the vice chair is Paul Harris from VIP Solutions. Just a sample of activities that we carried out in the context of the Trials Working Group. You can see recurrent activities of liaison with the 5G Observatory that is beyond the R&D community. Panel discussions or workshops in flagship conferences of the IEEE, like WCNC on energy efficiency aspects, or how trials and pilots may favor the evolution towards 6G from an experimental standpoint. That was a workshop in Amber last year. There's also the Trials and Pilot brochure that Didier nicely described. Also, other co-creation events in 5G territory, for instance, 2024 about lessons learned. And also there is this podcast, which is available from RSS platform on lessons learned from hosting vertical experience. You can see the projects that participated there for details. All right, and just to conclude, what is the added value of this Trials Working Group to 6GIA members and beyond? I have to say, first, that I consider this is a selected place for networking, where all the actors are involved, MNOs, verticals, also commission, research, community, etc., with over 250 members to date. There are dedicated activities to private trials, cities, verticals, international cooperation, as I already described. But the most important feature is that this is an open working group. So there is no need to be a member of the 6GIA member to participate, just express your interest, and you can join and participate as observers to the working group activities. Projects may benefit from increased dissemination opportunities and also get updated information on the trials being run by those projects. upcoming calls for proposals, project-related events, and also about the, say, elaboration of the SNS work program. And I would say many other things. So if you are, please, next. If you are interested, you can simply join by going to the CGIA website. You have the URL there, and you just click on apply to join the trials working group, and we will be happy to welcome you in the activities. And that's all from my side. Thank you very much.
Okay, thanks so much, Carlos. I mean, thanks to all of you. I know it's a lot of information in 10 minutes, but as I mentioned, we have a pretty busy schedule. So with that, I would like to hand over to colleagues from 5G ACIA, so Lisa Underberg and Niels Koning, to take us through a tour of what the trials and pilots activities in the 5G ACIA. So Lisa, the floor is yours. Would you share your screen?
I'm about to do so. Good morning, everyone. Just let me fix some technical preparation. So somehow it is very slow today. So thanks for your patience. And it doesn't really go into presentation mode. Sorry for technical issue here.
We cannot see your screen yet. I'm not sure if you have shared. Okay,
Sharing.
now it's coming. Yes, yes.
However, not so perfectly the presentation mode. I hope we can get along.
I think it's good enough. Yes, thank you.
Okay. So let's start with the brief overview on 5G ACIA's activities. Today is here my colleague Niels from Fraunhofer IPT and me. We are both the Working Group 5 chairs, and Working Group 5 in 5G ACIA is called Industrial 5G in Practice, and this is what our focus is in Working Group 5. And from our work, we selected these three items: the endorsed testbeds that we have, the device overview and the demo wall, and then finally the Industrial 5G user guide, which we'd like to introduce to you. So this is the overview of the testbeds that have been endorsed in 5G ACIA. We have 15 endorsed testbeds in 2021. I will explain a bit more about what a testbed is on the next slide. You can see that in 2021 there was quite a large group. That's because the colleagues have been waiting for the program to start. So once the rules were set, we had a couple of applications, then lots of work happened. This is why 22 and 23 there are just some few applications, and now in 2024 and also this year we start again to have some activities here. What you can see from this is that we look at diverse use cases: robotics, intralogistics, material handling, smart manufacturing, and so on and so forth. And also we're looking at different functionalities, for example, different frequency bands, functionalities like positioning, ambient IoT, interoperability. And what's unique about our program, or maybe not unique, but what I want to highlight, maybe that's more precise, is that we have a framework that testbeds need to adhere to. For example, our testbeds have to have at least 2 members to ensure good collaboration, and we allow also non-5G ACIA members to join the team, but only if there's 66% of 5G ACIA members. That's how we ensure that the learnings from the testbeds are also carried to 5G ACIA. We have a different framework for testbed scopes and testing types. By this, we make sure that the outcomes are also relevant for 5G ACIA members. And here we limit to some testbed scopes. Of course, other scopes are possible. It's always up to a peer review that happens for testbed applications. Testbeds have a purpose. They need to share detailed technical 5G information, and they have to determine their lifetime, their activities, what they will deliver to 5G ACIA, and also in what time they want to deliver that. On the right-hand side, you can see the 4 phases of endorsed testbeds, which also makes clear that our testbed program is rather an endorsement of joint testbed projects. We have an application that's been that is to write by the testbed members. That's subjected to a peer review, and a recommendation to the plenary is given. After that, the testbed may start working. During operation, we have these interim result sharing, and in the end, there's a peer review of all the results that have been shared. There's a check whether that's in line with what was targeted, and after that, if the testbed team wants to continue, and we had several testbed teams already wanting to continue, the team reapplies with new objectives and a new plan what to share with 5G ACIA. So you can see it's rather a concise framework that we have to ensure results are relevant. In our testbed initiative, you can find here a summary of the goals to evaluate key capabilities, to validate new features. Our goal is also to bring that into realistic scenarios. And this is just briefly, as I talked so much about the testbeds, I will be a bit faster now. The scopes and the testing types, you can see that we mainly have validation and performance testing, and in factory automation and intralogistics. And of course, we're hoping to extend that. And if you're interested, either if you are a 5G ACIA member or if you know 5G ACIA members, we can help you use the stage that 5G ACIA gives to our testbeds. And with that, I'd hand over to Niels for the next 2 slides, the device overview. Do we hear Niels or see Niels?
Yes, he's online, he's connected.
I can see he's not muted, but probably some configuration
Okay.
issue with the microphone.
Niels, if you solve that, please jump in. Otherwise, I just would explain your 2 slides.
Now you can hear me?
Ah, now it works. Okay.
Okay, sorry. Yeah, okay. So of course, one of the goals of 5G ACIA is to make sure that there is a vivid 5G ecosystem, and therefore we have some initiatives besides the 5G ACIA testbeds. So there's one item, which is the Industrial 5G Device Overview, which is actually a database which we made public, and it's containing a searchable database where the industrial user can look for the most appropriate device that he can buy off the shelf. And it has many different technical parameters that you can enter in the search form, more than 40 different technical parameters. Like the interfaces, like the footprint, like the weight or the voltage supply, but also IP grades, then a certain 5G features that are supported, then the 3GPP release parity, and so on. So you enter, and you have the search form, which you can use by the website or by your smartphone. Then you end up with results list. And if you click on the results, then it will show the detailed information about the certain device and listing all the different parameters. And then also you can export the data sheet from it. But of course, you can also browse to the product website or see the email address of the technical sales representative. Then we go to the next slide. There's also the possibility that we showcase some of the devices with the device, the 5G ACIA demo wall, which contains multiple different devices. More than 30 physical devices are integrated into the demo wall. The demo wall is typically shown at trade shows like the Hannover Messe. And we've launched this demo wall last year at the Hannover Messe, and now we had the more extended version 2 of the demo wall launched this year, but we have showcased the demo wall also across the globe. that may be China, or we will show it later this year in Helsinki and Tokyo. And maybe you can click once, Lisa. So the demo wall is containing, first of all, very simple industrial 5G routers, but also modules and dongles. So different form factors are integrated here. Then we also have demos where actually a setup of industrial 5G router plus field bus communication is showcased there. That may be safety or just Profinet communication over 5G. And this is showing there as well. And then we have different other form factors like sensors, like measurement devices. And then also we showcase the RAN infrastructure. So mostly the antennas are shown there so that the industrial user can understand how it will look like on his shop floor. And also we have a showcase of 5G core networks, but not physical, of course. But there is a video loop showing the different offerings of the members. Okay, that's it from my side. So Lisa, you're next.
Okay, then thanks, Niels. I will just briefly mention our Industrial 5G User Guide, which is in its first version online currently. This is also taken from the website. We identified the gap we have the test beds, here experts work together, and we have the demo wall and the device overview. Here you can check when you already know about 5G, but we identified the gap that we also need to educate end users or integrators a bit more, specifically end users, about what 5G actually is, because it's a bit different from what people mostly know already. And here, the Industrial 5G User Guide targets this gap by providing information that's tailored to end users or people who are new to 5G. We form two categories. When you start learning about 5G, for those who are interested in the basics, you can go to the left column and just go through some input that's there. You can also see there's coming soon, so this is planned for this year to be extended. And on the right-hand side, you can see or you can check if you're actually interested in deploying 5G, what background information is of importance to you. Here we're on one hand providing information, and on the other hand, if someone here from the web seminar has an input or something's missing, we're also open to take it over on our side and extend the Industrial 5G User Guide. This is really meant as a living document to help the ecosystem evolve. And with that, back to the moderation. Thank you.
Yes, thank you so much, Ilsa and Niels, for the very interesting information. So let's go one step deeper into the content with the set of the next four presentations, two from the SNS projects and two from 5G ACIA. I will then give the floor back to Didier and Lisa for the moderation of this session to invite the individual speakers. So, please.
Thanks a lot, Kostas. Very good. So we are now moving. We have 45 minutes with 4 presentations. So we will also ask you, we will be the timekeeper with Lisa. We'll ask you please to stop on time. We know it's a very short presentation by project, but it should also give us, let's say, clearly interest to go further. So from 6GIA perspective, we will have Janina, who will talk about Target X. As we have seen in the presentation, this will be Target X will be highlighted in the SNS brochure number 1, and we will have also Min Xie, who will present us the Imagine B5G project, and Imagine B5G is also highlighted in the SNS brochure. Lisa, you'd like to just to give the introduction from 5G ACIA perspective to the two presentations? Or?
I thought it would be better to do that right before they happen.
Okay, excellent. So let's start.
Start.
Yeah, indeed. Let's start with Janina. Yeah, thanks. Janina, please. It's your turn. Yeah, thanks.
Okay, I hope you can see my screen and hear me well.
Yeah.
Okay, yeah, my name is Janina Gauss. I'm presenting the TargetX project, and yeah, perhaps we first start with an overview about the project. So TargetX stands for Trial Platform for 5G Evolution Cross Industry on Large Scale. And it's part of the call SNS Large Scale Trials and Pilots with Verticals. So it's a Stream D call. We started in 2023 and we will end this year. And the main objective that we have is the acceleration of the digital transformation of the key verticals that we have in a project, which are energy, construction, automotive, and manufacturing. Using large-scale trials in multiple testbeds, evaluating 5G, 6G technologies such as real-time communication, localization, self-description, digital twinning, and sensor network data fusion. And we do so methodologically using KPIs and KVIs. For the consortium, TargetX is coordinated by Fraunhofer IPT, and for the technology partners, we have Ericsson on board from Germany and from Turkey. We have Neutrun, 5Com, and Qualcomm on board. And then research partners are for the IPT, and then RWTH Aachen University with 3 institutes and ITOCAT. And then there is this tool of financial support for third parties where we have Funding Box as a partner to support that. For the energy vertical, we have the ACS Institute for advanced power. For the from the Ion Energy Research Center, and from manufacturing we have Mapos, Mitsubishi Electric, and IPT, as well as the WZL from RWTH Aachen University, looking at this vertical. And then we have automotive, where we have IDIADA as a partner. And then construction, we have the individualized production chair from RWTH Aachen University, as well as the Center for Construction Robotics. So the testbeds for TargetX are at 2 locations. The automotive testbed is with the IDIADA driving ground. It's called 5G for Autonomous Driving, and it's in Tarragona in Spain. And the other testbeds are at the 5G Industry Campus Europe in Aachen in Germany. We have here the testbed for energy monitoring and the testbed for 5G for construction. And we have the 2 manufacturing testbeds, one 5G for mobile robotics by the WTH Aachen University, and 5G for cloud native production that is at IPT. So to introduce you to the overall TargetX project, we are aiming to integrate 5G in also new verticals. So at the beginning of the project in manufacturing, at least, it was already starting out, while there were other verticals not yet really starting out with the 5G topic, and we are integrating 5G also in these new verticals. And by that, we are learning from each other and creating synergies, for example, with the robotics from manufacturing and the robotics that are used in construction. That is one good example for such a synergy between the different verticals. So we have these different verticals and testbeds. And in these, we are integrating new 5G, 6G features. I will go into that in a second. And what we do there in the testbeds will be evaluated using KPIs, KVIs, and business models, so that we kind of really get an insight in how 5G can provide value to the end users. And then, as I already mentioned, we have this financial support for third party. And then we have quite a number of projects there, and they are an additional innovation driver, including a lot of SMEs that are doing trials in the project. So I promised to have a look at the technology. So we look at that from 3 angles. One is the network, second is the devices, and third is, of course, the services. And all the new technologies that we are integrating into the testbeds are listed here. So we have the millimeter wave, for example, the deterministic latency, positioning, service differentiation, and then there is the 5G network asset administration shell, and that is the one that I would like to also go into more detail with. First, the big question was, is the asset administration shell for the manufacturing? That's already quite, at least a known technology right now. So the AAS is a virtual representation of an asset, and assets can be nearly everything. So it can be machines, it can be materials, documents, can also be non-physical objects, as like contracts and orders. So everything in a factory that is of value to the company can be an asset in this for this concept. And the asset and the asset administration shell then together form an Industry 4.0 concept component. And as it's a mechanism or concept from manufacturing, we aim to kind of bring both worlds together, and that's why we have developed the 5G network AAS and the 5G user equipment AAS. And with that, we are kind of, we've been discussing what is relevant to capture from the network and from the device, and have been taking also into account, for example, these functionalities that are captured in the device overview of 5G ACIA. And I think there's also a 5G ACIA white paper on this topic that has been influencing our works as well. And with that, we kind of bring together an asset administration shell from the network and from the user equipment, and bringing it in the same environment that is also from the manufacturing. And this is not just kind of a description of the things, but we are also building this as a practical architecture. So we have the network and the UE sending data that we can constantly update in the cloud, in the edge cloud, so we can constantly have updated data in our asset administration shells. So TargetX has quite a lot of use cases, as we are a project for verticals. And we have that in the manufacturing, in the energy, in the automotive, and in construction. And this is the list of the use cases. And of course, we have quite a number more coming from the first and second open call support program, where the additional SMEs have also implemented their use cases that they bring to the project. For today, I'd like to give a short insight into the environmental condition monitoring use case and a little more deeper look into the edge-controlled automation use case.
Yeah, just we have 2 minutes, Janina. Yeah, thanks.
Okay, yeah, then I'll hurry up. Okay, so with the environmental condition monitoring, we see that we have a machine and the wireless sensor platform, where we have data coming from this wireless sensor platform, sending it to the cloud. So we have in the cloud then the condition monitoring that is taking place there, and it's kind of our sensor architecture that we have there. So we send the environmental data on energy consumption and condition monitoring, like vibration, temperature, and humidity, to the cloud, and this is then the foundation of the calculation of the environmental footprint of the manufacturing process. And additionally, this setup is easily reconfigurable using also the asset administration shell. Going to the edge robotics use case, we see here that we have this lineless disassembly setup for the remanufacturing of batteries of electric vehicles. And if we, our use case is then part of this automated disassembly that's part of this remanufacturing process. And what is happening there is kind of that there has to be an robot picking the battery packs, and it will start with localizing itself, detect the object that it has to pick, then it will grasp the object, and then start a dynamic path planning, and then place the object into this, here it's a desk. And what is perhaps special about this is, of course, with the lineless assembly, we kind of need a mobile setup. And then what is additionally interesting is kind of that all this, as this kind of more advanced, we kind of put this on the edge computing service for executing all these functionalities, which means that we have quite a high number of data that we have to send in the uplink, and then have quite low values that are sent in the downlink for the control variables. So what do we provide per use case? We provide per use case a general description with step-by-step, and we provide an architecture where we show you development and an architecture diagram. We provide the communication requirements and the KPI, KVI evaluation. And the evaluation in Target X takes place coming from the benefits that are generated from the use cases. So we take the benefits that we want to achieve and map them to the techno-economical goals and the societal goals, which provide us with key performance indicators and key value indicators. And if we have a look at this scenario, so we see that we have a use case that is providing a product, and this product will then generate a user KPI and KVI, which means the benefit. And so what I would like to highlight here is that the use case requirements, like the network KPIs that we place towards the network, are different from that what we kind of evaluate the use case with, as these are the KPIs and KVIs that are relevant to the user that has employed the use case. So for example, an example for the KPI would be the overall equipment efficiency.
Thanks.
And
Please, thanks.
And with that, I'd like to just shortly highlight the scale of testing at Target X. So we have 26 FSCP projects in the first open call with 33 entities, and currently are running our 40 FSCP projects with 65 entities. And this means that we have so far more than 20 applications implemented, and we will be at Automatica in 2025. So in June, there will be an event for dissemination and networking. And with that, thank you very much for your attention, and giving back to you.
Many thanks, Janina. Very, very great, and very great project. So thanks a lot. I propose we take the question in the panel, in the discussion of the panel. So I propose we go with Min on Imagine B5G. So after Target X, Imagine B5G, before we go to 5G ACIA. Please, Min, go ahead.
Yes, thank you. So let me share my screen with you, and yes.
For the time being, we don't see.
Can you see my screen?
No, not yet.
No. Okay, let me try again. Screen one. Okay, let me try again. I think WebEx probably does not like. How about now? Still no?
No.
Sorry, can you give me to join from web, because I use the app, and which probably cause some issues. Can I give me one minute to join from the web?
My proposal is that we may directly move. We will take your presentation just after, and we may take 5G ACIA in between, if it's okay with Niklas, and if you like also Lisa to introduce, please. And we take Imagine B5G just after, please go.
Did I like the idea? So Min can rejoin. Niklas is already here, I assume, and getting ready to share. Niklas is with Fraunhofer IPT and presenting one of two 5G ACIA testbeds that we like to introduce today to you. The first one has a unique feature, the only testbed so far that we have that is working with millimeter wave. And Niklas, I don't see your screen share yet.
Yes, I will do it in a second.
Okay. Yeah,
okay,
a bit surprising, I guess.
No, it's all good. No problem at all. I clicked share. You cannot see it.
Not yet. Well, maybe now I'm mentioning to Harsha already. Harsha, please check whether you can share later.
Okay, can you see my screen now?
Yeah, it's coming up. Not yet your slides, but your
Yeah,
screen.
hopefully now my slides are visible.
It's
Yes.
okay. It's not in full screen
Okay.
mode, but it's okay. Yeah.
Okay.
Yes.
About 10 minutes, Niklas. The floor is
Yes,
yours.
okay. I speed up a little bit. Thank you very much. Yeah, thanks for joining, and good morning also from my side. I quickly want to introduce our millimeter wave testbed and generally, millimeter wave for industrial applications. Shortly, my name is Niklas Beckmann. On the right side, you see Niels König. I think you know him. He is here the coordinator of this testbed. Okay, since I don't know how much you were in touch already with millimeter wave technology, I want to give a quick motivation for 5G millimeter wave in industry. Why do we even want to use millimeter wave technology? One point is that in the millimeter wave domain, we have access to a much higher bandwidth. So in Germany, it is around 800 megahertz in total. And if you compare that to the sub-6 domain, you have a maximum of 100 megahertz. And yeah, with the bandwidth, of course, there comes the enhanced performance. What you find with millimeter wave is potentially a higher data rate and also a lower latency. Usually with millimeter wave technology, you would not radiate from the antennas in an omnidirectional fashion, since therefore the path loss is simply too high. Therefore, you use beamforming technologies, and these lead to small areas being covered by the beam only. This you can use for the interference management. So if you point your beams in two different directions, they will not interfere, as in the sub-6 gigahertz domain. Of course, millimeter wave technology comes with some drawbacks. I told it already a little bit. So we have a higher free space path, free space attenuation here. And another thing that is very limiting in industry is the obstacle penetration. So, for example, in a shop floor like ours, you have big machinery. You will see it later in some pictures. The millimeter wave beam will be completely blocked by these machines. And you have to find some ways to also bring the coverage to these areas, for example, with the help of reflectors or other technologies. But generally at our testbed, we want to analyze the performance characteristics of millimeter wave, the propagation and network quality. We want to see if different radio configurations can influence the performance of our network. And we also want to see the influence of the 5G UE configurations. And then, of course, as we always look very much from the practical side, we want to implement use cases, or we already did implement some use cases regarding high uplink and downlink demand. Yeah, and generally the goal is to evaluate how robust millimeter wave technology can be in the industrial context. Yeah, quickly, what our testbed partners are. Ericsson brings the network, the infrastructure and measurements. Qualcomm and Basler are also on the measurement and device side, but Basler obviously is especially localized in the use case area. The testbed is located in Aachen at the 5G Industry Campus. Yeah, we have a 5G SA and NSA network, so we have both LTE and NR at our place. And there you see the two frequency ranges in the 5G area is this FR2, so-called, is the millimeter wave domain, which is 26.7 to 27.5 gigahertz. So we have the full 800 megahertz here. And in the sub-6 we use the N78, typically is used in private networks between 3.7 and 3.8. As I said, we have a large shop floor with a lot of machines, but I think I will come to this in a second. Here again is the outside area of the 5G industry campus, and this little building here is the IPT. Yeah, well, it's not so little, it's only little on this picture. What you see here is one of our shop floor aisles, and here on the ceiling you can see the millimeter wave and the LTE antenna. Okay, now a quick presentation of some measurement results that we did recently. This one was especially conducted with the partners from the Technical University of Dortmund. What we did here is to create a RSRP heat map of our shop floor. So the millimeter wave antenna in this map is located here. And what you see is in the line of sight areas, you have a very good connectivity. So red indicates that you have a high RSRP. And when you move to the bluish and greenish areas, the RSRP gets lower. And even here in the corner, you have no connection anymore to the network at all. So you're not able to obtain any RSRP. What is also interesting to show is in this map the beam indices of the beams are indicated. As I said, you use beamforming technology, so you point your beam a little bit like a laser pointer, but of course wider towards different directions to reach the coverage there. And what you see on this line of sight areas, you have areas for one beam index. But in this area, for example, where you have a non-line of sight area, you see a very colorful, let's say carpet, indicating that you have a lot of reflections there. You have not one beam index area, but many different beam indices. Probably what we think is that they result from the reflections due to all this metal in our environment. Yeah, of course, it is also important not to just have a look on the aisles, since the machinery often is located next to it. And also if you have mobile robots who have to pick up some work pieces from the machines, they might have to leave the area of line of sight. So we did also some measurements between the machinery. And what you see on this map here is you have different so you have this C is the line of sight points, and as soon as you leave the line of sight, the signal drops a little bit. But in this area, so our view is now directly from the antenna. We see, for example, M1A as an example is here. We don't see a signal loss here since we have a direct line of sight. For the testing purposes, we placed another antenna here. And what you see is when you move then between the machinery, the signal drops significantly, and in some areas even it drops below the receiver sensitivity and we lose the signal. Now a little bit, I have 1 minute left, a little bit what is the future that we plan. Of course, we plan to do additional coverage measurements at our place. So there is still a lot to be tested. We want to do also some mobility measurements as some additional effects like Doppler shifts and so on comes into the game. Then recently we got another millimeter wave cell at the other edge of at the other end of the shop floor. So we are also wanting to try the millimeter wave handover measurements here. Yeah, generally 5G measurements with the dual connectivity, so to be connected with the sub-6 and the millimeter wave domain at once. And also, for example, to reach the areas with non-line of sight, we plan to make measurements with other technologies. Only one example might be reconfigurable intelligent surface. Last slide for me, some use case implementations that we are planning now is on one side to have a mobile AGV in our shop floor. The mobile AGV should be equipped with LiDAR and camera systems, and we want to send this data, yeah, to the network and do the image processing on the network or on the cloud, and then transmit to the robot the control data to for example solve some pick and place tasks or whatever. So it's a very uplink heavy use case. And on the other hand, we could imagine emulating a data shower use case for high downlink demands here. So the idea would be to have systems that need to be flashed with a certain software, and during the production, the workpieces get into the area of coverage and are flashed with the software in a few seconds. Okay, then sorry for the rush, and thank you for your attention. If you have any additional questions, of course, feel free to email me.
Thanks.
Thanks, Niklas. We
Yeah,
also
thanks.
have some time for discussions during the panel
Yeah.
In a bit.
Exactly. I propose we go back. Yeah, we go back with Min. Thanks,
Yeah.
Lisa. So we go back with Min for the next presentation. So Min from Telenor,
Yes.
talking about Imagine B5G. Can you share, please, Min, for 10 minutes? Yeah.
Yes. Okay. I will see if I can share. And,
If not, Costas will share.
yes.
It's
Can
okay,
you...
but we don't see your presentation. Yeah, okay. And if you can pass in full screen, yeah, it's fantastic. Thanks, Min. You have 10 minutes.
Okay, great. And you can see my screen now, right?
Yeah, fully. Yeah, thanks.
Okay, great. Thank you. So I will give a 10 minutes presentation to overview what we have done so far to support the trials and experiments in the Imagine Beyond 5G project. First, a quite quick overview about what is Imagine. It is a Stream D project with 17 partners from 9 countries, and we kick off the project in January 2023. It will end the project end of 2025 this year. And among the 11 million euro budget, about 40% is used for the open course, the cascade fundings, and the open course in the Imagine projects are divided into 2 groups. One is to extend and enhance the platform so that the platform can have more advanced or extended features to support trials and experiments. And the second group of open course is what we call the vertical experiments, which aim to investigate and explore different use cases in different verticals. In Imagine Beyond 5G, we have focused on 7 verticals: PPDR, education, industry 4.0, media, healthcare, agriculture, forestry, and transportation. In this webinar, I will just focus on industry 4.0. So before that, I would just also give an overview of the platform of the Imagine Beyond 5G project, which is a combination or federated combination of 4 facility sites located in Norway, France, Portugal, and Spain. I'm sorry. Each of these facility sites has its own special design, deployment, and the features. For example, the Norway facility is targeting more mature 5G options with based on the near commercial solutions with both the private and the public 5G. France facility is more into the open source 5G based on the open air interface solutions from the Eurocom. Portuguese side is a combination of commercial and open source solutions, like they use the Huawei radio, but they also use Open 5Gs. But the main 5G network types is private 5G. The Spanish side use the public 5G from Telefonica, plus several private 5G networks, which are also based on the near commercial solutions. So what you can see is we have a quite wide scope of 5G options, from private to public, from near commercial to open source, which gives the flexibility to support different use cases from SMEs, from research institutes and research institutions. So the platform is a federated combination of 4 facility sites, and these 4 facility sites can be interconnected and even interoperated. For example, the Spanish and the Portuguese site going to be interconnected and to interoperate to support the use cases which will span both the Spanish side and the Portuguese side. We also offer the developer portal on top of the customer portal. We offer the developer portal to allow third-party developers to not only use, consume, but also manage the 5G platform. Last but not least, we offer testing and validation as a service across all the facility sites using the testing tools provided by Keysight. Now we comes to the open course. The Imagine Beyond 5G has released 3 open course, and the 3 open course now basic for the vertical experiment open course, we basically cover all the use cases of the 7 verticals, as you can see from this table. So for the webinar, due to the time limit, I will focus on the Industry 4.0, and I'll pick up one open core project from each individual open course. ALMA, AI Gloves Human Activity, is an Industry 4.0 project from the first open core and sponsored by the Norway facility. And the TRI level is 7, we're relatively mature. And the objective of the ALMA is to combine the AI and smart gloves and 5G connectivity to allow automatic documentation of operation assembling in productions. It can be used for training, optimization, and real-time assistance. So on the right side, you can see the 5G setup, which is quite straightforward. The 5G UE devices are provided to connect the ALMA gloves and the laptop servers to the 5G network so that they can communicate each other. And the laptop and the controllers or operators, instructors can use the laptop to send the instructions to the gloves. So to help the labor workers who wear gloves to assembly the units. This is the demo provided by the ALMA project. The accomplishments of the ALMA project includes the 2 trials which were conducted in the Norway facility. And I will just jump to the setup very quickly and the result. In the Norway facility, here I want to highlight that the Norway facility can support large scale trials, but it does not have a traffic generator. So in the Norway facility, we only test the real one pair of gloves using the 5G UEs, including mobile phone and the CPEs, as you see in the setup diagram before. And the performance or KPIs achieved are satisfactory. And basically, the performance is much better than especially the latency, than what they have achieved using the commercial and the Wi-Fi network. One problem with the NOI facility is it does not provide the traffic load that can stress the network and show the performance while for the ALMA, while there are many pairs of gloves operate at the same time. Therefore, ALMA then moved to the collaborate with the Sandbox, 60 Sandbox project, and run another large-scale trials in Malaga using the Keysight physical traffic generator, which can simulate 150 pairs of gloves. So that help us to scale the ALMA trials from the single pair to 150 pairs. That will show how the ALMA really behave and the network behave under the heavy traffic load. And so this is the result. I'll just jump to this. This is the results they have achieved using the traffic generator on top of the single pair of physical gloves in the Norway facility. And you can see even with the scaling of 150 pairs, the performance for the 5G network still supports the ALMA requirement in general. And this I will skip the details of the KPI and the KPIs, but that in general, ALMA is successfully completed and with all the KPIs and KPIs validated. So that is the open core 1. How many minutes left?
1 minute, please. Yeah, 1 minute.
So Open Core 2 setup that is ongoing, and this is also sponsored by Norway facility. The setup is actually quite similar, robotic arms, but this time the setup project designed their own 5G enabled sensors and with the cameras, which will be mounted and integrated with the robotic arms. So on top of the sensing on transmitting sensor signals alone, this setup project will transmit both the media and sensing signals and data to the controller. So the controller can see, using the AR glasses, the controller can have the more multimedia experience to instruct the actions and operations of the robotics arms, and can, with the AI capabilities, can also probably adjust the operations to make it safer and more robust for the assembling operations. This is ongoing, and that is the 5G setup. The challenge for 5G setup with regard to the 5G trial support is they develop their own 5G enabled sensors, which needs to be validated in the 5G network. So it is not straightforward or that to the 5G network developed in the trial in the platform can support the devices they manufacture themselves. So that is the challenge we're facing. Pulse 5G, the last slide. So it's an Open Core 3 use case, and that is also some that is for PLC as a service. So what they will do is they would also have sensors and motors, and on top of that, they will provide their own simulator to simulate a PLC or the sensors. So this is similar to ALMA, but instead of using physical traffic generator, they use a software traffic generator to simulate thousands of sensors and the data generated by sensors. And this is still in the early phase, and so far we have completed or finished the architecture design, and that is the setup for the trials. That's all. Thank you.
Thanks a lot, Min. Very comprehensive and very good work here. Thanks, Min. So we go and we take question. You can pass by the chat, and we will take question and further discussion during the panel. So please, Lisa, with the last presentation.
Yeah. Next and last presentation of this slot, I'd like to introduce Harsha Master to you. Harsha is with NXP and very experienced with 5G ACIA endorsed testbeds, as he is working now in his second testbed. And I assume, Harsha, you're about to share your slides. Your mic is already working. That's nice.
Yep. Thank you, Lisa. and very interesting.
So while Harsha is sharing, the second testbed we selected in 5G ACIA is about end-to-end communication of TSN over 5G, which is for the industrial automation domain also very important topic. And we can see your slides now, Harsha. The floor is yours, 10 minutes.
Okay, thank you, Lisa. And very interesting presentation, last two presentations. I think my presentations are a little bit different, and also I will try to make it more interesting or some interesting for you. And I would like to take an opportunity to share two of our 5G ACIA approved testbeds and our experiences in executing them. And these are the two presentations, the two testbeds of what you see here, one executed in 2022 and the current one is in 2024. And about me, I am Asha Master from NXP Semiconductor. I'm a principal architect at here, and I'm one of the team member who works in 5G ACIA testbeds. And more from my point of view is I do a technical support to my colleagues who actually run the show. So having said that, I would go to the next slide. What I would like to do is I would like to quickly go through the two test beds, what we the one which we have done previously, and what the another one which you are currently executing. And also I will go through the some test aspects of it and some dissemination points of it, and hope to present you some learning of what we have done, learnings we have done of, in these two. And I would like to, before I start the next slide, I would like to say that these testbeds are unlike the funded projects. These are self-funded equipments. All the things what we do in the testbeds are brought by our testbed partners, contributed in these testbeds. So all of the things are self-funded in that say. So to present my first our test bed here, this is about the Profinet over 5G. That is what we did the test in the test bed. The scope of this one is to bring the evaluation. How does the Profinet behaves on the 5G test system? And here I have a very simplified system and test flow here. You can see. I hope I can get the mouse here. So the two PLC and I/O controller are the wired systems, and we have the 5G system with the base station and the radio net and core network here. And there are two, one of the UE here is connected to the 5G system. Another one is directly connected. This is one of the many combinations what we did. This is, I placed it to make sure that I can explain it in a little bit easier way. And in this testbed, we had 4 partners, IFAC and HMS, NXP, and Redisys. And we have contributed to different aspects of this testbed. So as you see, the two PLC and the PLC and the Profinet are the Profinet devices. They are the wired traditional devices. And here we would like to measure the Profinet traffic over the 5G system. And to achieve this, what we did is we connected over the Profinet tunnel, what we call these two devices. Because of the wired devices, they need to go through the tunneling, and then these two entities enable such an tunneling capabilities. And then the measurements really happens on the IFAC provided multi-phase measurements, where the measurements capabilities, the test measurements capabilities stay with that responsibility of the multi-phases. So how what we did is to, the first step is to connect the entire system using, the system is there, but to measure, we did 3 steps. The first step is to evaluate the system capabilities between the end-to-end system only in the 5G. So that's what we did here. The measurement happens between the pure 5G system, between the UE and the base station. And we took the measurements of this, we keep it as a reference, and in the next step, we emulated the Profinet traffic over the same system. Again, we took the matrix using the same system, and at the later, we did the actual Profinet devices communicating each other, and then we measure all the things here. So, as you said, so here is after this measurements, this is one of the test results. You can see a comparison between wired and wireless matrix. This is just an example, and this is about 95% of the measurements on average, and the wired is roughly about 45 milliseconds, and the wireless is 52 in a particular condition. It's not in the best condition, but is in one of the conditions. And if you look at both of them, they look similar, isn't it? But however, you can see the outliners here. So this is how we detect. I mean, this is one of the ideas where the testbed comes into picture. Where we measured the wide measurements is clearly much better, but there are many reasons, and these kind of reasons we would like to detect and determine and evaluate in the testbed. With the testbed partners, we bring they bring the knowledge, we know together, share together. That's how these outliers, what happens, why it is there is why is the ramping of the signals, such things as part of our testbed activities. And you have a second one, a similar one, and this is just an example as an example. So if you look at this, there is a flat signals. It looks so nice, but this is when we do it emulated, means without actually Profinet devices. We emulated that Profinet traffic over the systems using the simulator, and it looks so nice because we don't see any problems. But in reality, it is different. It's completely different. So this is exactly how we also, from a realistic to a tested environment, we able to detect or determine the system behaviors in different environments. Right. The second testbed, that was the Profinet, and this is the current testbed which is happening. This is about doing and bringing the TSN onto the 5G network. And here we have many partners, Belden, IFAC, Moxa, NXP, Redsys, Mitsubishi, Schneider, and the University of Stanford, EMRC. Here again, this is all self-funded. Each of the partner provides the equipments, and this is how testbeds in 5G ACIA mostly work. And in the purpose of this one is to first build the TSN network. To build a TSN network, we know that there are not TSN-enabled existing devices in the wireless domain or 5G domains, so they are existing in the wired domain. So we make use of the existing system, build a network, and then slowly find and evaluate what is required to enable it as in 5G or the TSN or 5G system. This is an example, and how the testbed is much easier if you enable it from the partner's perspective. What we did is our first challenge was to build a 5G system, so with the existing test components, and our first target was, okay, let's do the first thing using it, Hanover Messe as a first milestone. And look at it here. So this is the picture. What left showing is in the 5G ACIA booth in Hanover Messe 2025. and this is in the OPCA Foundation testbed. Part of the testbed is split into two. The one part is staying in the one booth, and third is another booth. To build this from just in 4 months, this is the sketch we did. So, for example, in the 5G ACIA, the whole idea is in 5G ACIA booth, we will have the robot, and in the OPCA, we will have the controller. So, using the controller here, we could able to control the robot arm in the another booth. It is physically they are in the different booth, and I don't go into the details how they are connected, but I would like to point these equipments are connected via wired TSN, and we would later convert them into wireless. And this is also wireless as of now, but they are not true TSN. There's no TSN traffic happening, but they're pure 5G traffic. It was also gives us opportunity to learn what are the basic problems. For example, we start with the basics. So here, all the things we use the equipments from the bells and boxes devices you see. We start with the basic problems and we start evaluating what is required here. Once we have achievable system, working system, we also put the test cases into the action. Yeah, so that's is it about, and then I would also like to see in the previous exhibitions we also demonstrated. I think the first one, the left one, is in the say in Chicago. This is the middle one is in, let's say, in 2023 in Germany, and also we have other side 5G industrial expos here. So we have presented this demo. This is a partner efforts, and yeah, we had a great success, a lot of interactions, a lot of learnings thing, and that reminds me to go to my last slide about the learnings and perspectives. So there are a lot of things is similar, but it's also different from the funded projects, right? So this is, as I mentioned at the beginning, because each of us, we bring our own resources. It is being self-funded by the company because we would like to achieve something in this context, which also brings us a lot of responsibilities, a lot of reasons to feedback to everybody. And I don't want to read through this one. What the highlight we share a lot of technical things and beyond, right? So we a lot of our partners bring a lot of expertise in different domain, and also we would like to discuss in a several different way, and that's how it's also beneficial for us. For example, as I said, we share resources. It may be devices, it may be human resources, it may be technical resources, or beyond. And the opportunities is that we collectively go together. For example, some of us are partner in this, are actually competitors in the outside thing, but in the fairs, it also gives an opportunity to share the demos, demonstration, presentations, and have an equal talking. And also one of the great things about the 5G ACIA testbeds is whatever we do, this can also be shared in a different format. For example, the demos we built under the 5G ACIA context, we asked our partners, hey, we have a great event in NXP. Can we do that? Can we share this? I said most of the partners are very happy. They help us in contributing to their devices again. For example, yes, here, this is one of our industrial showroom in Hamburg. They contribute such things. So we are happy that we have the partners.
Yeah, the time's way up.
Okay, just one line. So as I just want to close here, we had a great 5G ACIA supports here. With I want to promote a little bit here. It's a perfect environment. What we can we always had a fine right partners, and that this is the best OT ICT ecosystem we can see. And the best of the best is that we have a systematic approach to solve and identify, evaluate whatever the test things we would like to do, and also the disseminations of the publications for the focused audience. Yeah, that was my last slide, and that is me. If it is not seeing the white, snowy angel looking now, but this is how I look, and this is also one of the results where we presented in IFTA. We are happy to share if you have any questions, please. No. All right.
Okay, thanks, Harsha. Also for advertising the 5G ACIA testbed benefits. I guess you just stop unsharing your screen, but you can stay unmuted probably for questions because the panel is next up.
Yeah, thanks. Carlos, yeah, we go, thanks a lot. We go now to the panel. So please, Carlos, if you can share and start, and we welcome also Marco. Yeah.
Let me share the slides. I will start in a second. All right. All right. Can you see?
Yeah.
Slides.
Yeah. Good.
All right. So let's get started. Welcome back again, everyone. So for this panel session, which, as you can see, is jointly organized by CGIA and 5G ACIA, the plan is to discuss about these 3 main points, right? What are the lessons learned from the realization of those trials? What are the key takeaway points? I mean, what we learned, where 5G helped, the 5G empowerment, and the pain points, that is where 5G does not help, say, in all fronts, right? For industry and manufacturing trials and pilots. So let me go to the next slide, where you can see the names of the panelists today. The first 4 are those who presented in the previous slot: Janina from TargetX, Min from Imagine Beyond 5G, Niklas and Harsha from 5G Asia. And let me also welcome Marco Gramaglia from University Charles III in Madrid, who is a leader of trials not working package, or package 2 on platform and network solutions. So welcome everyone. And for our discussions today, and along with the title of this panel, I would like to start asking you, I mean, about where 5G or beyond 5G technologies help. What are the features, such as, I don't know, low latency virtualization, or the fact that we are able to use a microwave technologies? Where it was useful? I mean, what are the technologies that proved particularly useful in your trials and pilots? And I don't know, question maybe addressed to Marco, Min, Niklas, I don't know, take the floor. If you want to say something, please.
I can start. Sorry.
Go ahead, please.
Yes, okay, I can have a quick start for the Imagine Beyond 5G project. We have actually implemented many advanced 5G features. From our point of view, like I'm leading the Norway facility, virtualization is very important, especially while we wanted to provides the platform to third-party application developers. So there are most of the apps currently are containerized. So virtualization and the orchestration based on the virtualization is particularly cloud-native virtualization is super important. And we need to simplify the onboarding process so that all the applications can be properly and quickly onboarded to our platform as part of the on top of the 5G platform, so that we can offer enrich the communication services to the verticals. It is a combination of apps plus 5G components. So I would say virtualization and also automation is very important. Yeah.
Virtualization and automation makes an important case for your trials. That's good to know. All right. Harsha, were you willing to say something, or who was?
Yeah, sure. I think one of the thing always I see is the low latency. Yes, low latency is very much required in a lot of sense, But in my point of view, I would say that I'm more for the determinism and the reliability point of things. So such a things we need because I have this kind of opinion, low latency versus the determinism. I also use that kind of trial, use the trials and the polish what we do in the different projects. I make use of them.
All right, so latency is important as well. Any other views on this first question?
Yeah, what I want to mention particular here is also the high bandwidth. What I did just last week was integrating a high-speed camera to our network, and just for the fun of it, I tried also in the sub-6 domain and in the Wi-Fi domain. And of course, a high-speed camera has a much higher frame rate than a normal webcam or something. And it simply was not possible to keep the stream up over the sub-6 gigahertz. So here the high bandwidth is really also an important factor for us.
Very good. So after discussing where 5G or beyond 5G technologies help, let's go to the next step. In what beyond 5G technologies for short, and what are the enterprise needs that remain unattended with this in the industrial automation vertical? Are there any new use cases or requirements that are poorly addressed with 5G evolution and that maybe for them 6G may come to the rescue? What are your views on that? I don't know, maybe Janina, any views on this?
Yes, so what we see for 6G or what we would wish for 6G is kind of a higher flexibility actually. So in the robotics use case, for example, that I presented, we've seen that we have very high demands in uplink and not so high demands in downlink. And then there are, of course, use cases such as a data shower, where we have high demands in downlink and not so high demands in uplink. So, of course, kind of the network can be parameterized, but yeah, to fulfill this need, but kind of the change between those fluctuating requirements is something that we would kind of wish for. Yeah.
Many thanks, Janina. Any other comments or points? Of course, I mean, as a general message to our panelists, I mean, feel absolutely free to disagree at any point in the discussion. This is a panel, right? So we are here to discuss and express complementary views. I don't know, any other points? I mean, any other, say, use cases that you could say see coming up and that are not well served by 5G?
Yeah, I have one point here is about this is again about 5G and 3GPP, non-3GPP wireless technologies, and also we compete in the context of the 3GPP, 5G. Why the 5G? Why all these things? I think some of the things I always wonder is that, for example, the critical services or non-critical services. We say, okay, we in the Wi-Fi is good for the video streaming, and then it's also equivalently the 5G, which is giving more reliability and such things in doing, for example, the operational support in the theaters and something like that. But these kind of different technologies should be not up for the debate. Should be integrated in the future technologies, whether it is. If we are talking about 6G, I would say that all these things, different kind of things, should merge or converge, or they should evaluate into a 6G. Otherwise, the 6G should be. The 5G, we say if it is moderately successful or less successful. If you want to make a 6G, these things should be integrated or accommodated different technology, different aspect of the use cases. This is what I would like to see in 6G.
Many thanks, Harsha, for your views too. Very interesting ones. All right, so now let's say focus on another pillar of our conversation today. So your SNS trials and pilots have been run, and also the 5G ACIA ones, have been running for some time now. I guess there were a number of lessons learned from the realization of those pre-commercial trials and pilots. I mean, they can be both technical or non-technical. It can also be practicalities arising from the trials and pilots. I don't know. Any way on this? For instance, Marco. I mean, from your project.
Yes. So from our experience in this more than 2 years of working in this area, I would say that there are mostly two, and one is technical and the other one is non-technical. So starting from the non-technical, I think that actually getting closer to the vertical to actually understand what are the requirements that they need is really fundamental. So for instance, in the project we have done, we are using like techniques such as the design thinking methodology, where we jointly design the use case to really understand the needs of the vertical. And the second one that is technical is the availability of the commercial equipment. So for some of these use cases, we really need something that was only included in the very latest releases of 5G. And sometimes you couldn't really find the hardware like CPE or other hardware solution that could support that functionality. So in principle, it could be done, but then when you had to deploy the network, it was harder because of the commercial availability of the solution.
Many thanks, Marco. I think it would also be interesting to know, I mean, say, the perspective from, say, the vertical side. I don't know if Harsha or Niklas have some views on this. I mean, about lessons learned, both technical or non-technical.
Yeah, I think I totally agree with Mark. I think this is a classic example. You don't get even the release 16, 17 compatible device as of today in the market, right? So without those devices, how do you execute the use cases? There have to be some kind of custom-made prototype. And from my point of view, even I have several projects which exactly NXP, I am catering such requirements because our partners are missing such features, and we are trying to provide that missing gaps where the commercial UEs are not capable of releasing 16 and 17, and we are providing such devices in a limited scope. But anyway, I have several points where we have, I mean, at least I execute several funded projects, and even in 6G and advanced 5G government-funded projects. So the most thing is that when we execute these kind of projects, the projects are executing in almost realistic. It's not like a lab environments for us. It is almost, we are putting into the field, try to understand the realistic environment. That's the one thing. The second thing, what I also see is a multi-vendor. In the setup like this, even Annie showed there's so much big projects she's shown up. So in this, when you are integrating multiple devices, the interoperability is the biggest challenge, and then we are not need to wait till the end product to become interoperable testing or the compliance testing. In this kind of setups, what we do is it's a learning for us that we put our interoperability in the early stages, so we don't see surprises at the end. And also, it also, when we are trying to integrate in a bigger setups, when we do several different projects, every project has a different needs, and even the customers and the partners' needs are different. So it's very easy for us to start engaging the requirements of the early stage. That's how multiple things play a role here. So maybe one more point I would like to see is in the standards what we are defined in the bigger form, the reading of this depends on who is reading it. So you can always make an interpretation different. The engineers who are not part of these kind of discussions interpret this specification differently. And if they implement at the end, we are trying to do comply to the systems, it is different than we put these engineers in these prototype college projects. They learn a lot of things, collaborate in the system with other partners. I think this is one of the best things what I would say that benefited from the trials.
Many thanks, Harsha. Very valuable insights as well. Any other lessons that you would like to share? I mean, from other panelists?
Yeah, actually, I think this for us, as Harsha said, actually, with all these new solutions, technologies, and devices, integration is very important. And we have been working with many vendors and stakeholders and use case owners, and they all bring their own solutions. And it is a big challenge for the platform to integrate all of them, make sure they interoperate properly. And that is why I think from our experience, it's good to have a diversity in the options. So we have a different 5G network instances with different vendors, so that if this option does not work, we can try the other vendors. And I'll give you an example like a RedCap. And RedCap is a new feature we recently added to our platform. And some vendors claim they support a RedCap, but then it turned out the device is not supported by this network vendors. And then we change it to a different vendor. Then the network feature is of RedCap is indeed supported. Then we got RedCap device manufacturers. They bring their own devices, which unfortunately then are not supported. So, but then the good thing is we have different options that allow us to keep trying. And if we fail, we try new options and alternatives. That is very important for us either to succeed. The other one I would like to probably to reflect on what Lisa said before about educating the verticals. This is a very big lesson we learned, because the verticals, they have their own idea about 5G, which may not be fully aligned or consistent with what we really build. It's very important for us to educate them, make sure we're on the same page. And while they raise up the requirements toward 5G, including KPIs and the use case trials, we make sure these requirements are realistic. So for us, I think education is very, very important part of these large-scale trials. Yeah.
Understood. So the importance of, say, equipment integration and education in the vertical. That's very, very interesting as well. All right. So since time is really short, let me go to a final question. All right. Oops, this one, which is a question addressed to all. So take the floor if you have something to say. It's about regulatory or policy factors. So it's about running pre-commercial trials and pilots so close to exploitation. So the question would be here if you've experienced any policy or regulatory factors like, I don't know, data protection, electromagnetic compatibility, or safety regulation in plants, for instance, which have really impacted the realization of your trials. If there's this is the case for any of those, please raise your hand. I was thinking of maybe safety regulations. I mean, making sure that, say, workers are protected and these machines are safely managed. Does it have a role to play, or has it had a role to play, or maybe it was more closer to research those trials and pilots? Just wondering. If not, we can close. All right, so let's leave it as it is. And I think this is all from our side. Very interesting discussions, I would say. Thanks for your contributions and for sharing your thoughts. And I take back the floor to who is leading the last part, It's, I think, Didier again. So it's
Yeah.
for yours now.
Yeah, thanks. With
Yeah.
Okay.
also, yeah, with also Lisa. Oops, can you see the slide? It's okay.
Yep.
Okay.
Yes.
I will pass in full screen, but yeah, thanks. So thanks, and thanks again. We knew from the start that timing will be short. So thanks again to all of you for keeping the timing. Again, this is the first joint webinar as such, and we clearly envisage, of course, further interaction and further, let's say, synchronization on the trials and pilot. When we met in Nuremberg, we also addressed the possibility to make potentially a dedicated webinar on ISAC, GSAC, also potentially. So this is just, let's say, a first webinar and very, very interesting webinar. So very quickly with Lisa, just to highlight you some key points, let's say, beyond this webinar and what are the opportunities. So I'm starting first with the 6GIA and Lisa will expand and extend with the 5G ACIA. Just to highlight, let's say, among others, the forthcoming the work program 2025 and the opportunities. So the document is officially published. The call is open for Stream B and Stream C. So basically, if I make it short, the enablers and the platform, not yet open for the trials and pilot, hopefully soon open. And you see this so-called Stream D01 is dedicated for trials and pilot with vertical, like in every call of SNS. And there will be 24 million euros of European Commission funding for project of 6 million euros. Okay, and then you see further opportunities, but we will not address it now. I just extract from the officially public document that you can find at this URL. But again, the call on Stream D is not yet open. So for project of 6 million euros, what is important is we can see in the work program the prioritization of 5 specific vertical. Okay, so this is one point to keep in mind, including industry manufacturing, including robotics. So this is one of the 5. There will be 4 projects, and the way the code is formulated is that there should be one maximum 2 vertical per project, and there will be in the evaluation selection the guarantee that the evaluation selection will be based on the score, on the score of the proposal, but also should lead to the selection of different vertical per project. So with a guarantee targeted that there is no, we don't see 2 specific projects addressing the same vertical. Okay, so 1, 2 maximum. There should be a center of gravity for each project. So a major, let's say, vertical plus potentially a second, but with a minor, let's say, priority. And then there will be one vertical per project. So you see, basically, this is just among other one of the opportunities. I'm stop sharing here, but it's important to highlight, and please stay tuned when the call will be officially open with a deadline if you are interested and if you'd like to contribute. So I pass the hand to Lisa now before we conclude.
Okay.
Lisa.
That should be coming up. Yeah, I've just compared one slide for 5G ACIA's perspective. As Harsha also mentioned, we don't have, we're not funded projects. So for us, it's rather contribution driven from our members. And I would like to highlight, highlight 3 aspects that we're focusing on in 2025, especially, or let me highlight, not in 5G ACIA in general, but in the working group Industrial 5G in Practice. We want to continue on our endorsed testbed program. As you have seen, they have strict rules and also they are not funded by 5G ACIA. Therefore, we get teams together that are highly interested in collaborating. And this is what you will get an insight to in our testbed brochures. They will be available online. They have a uniform formatting, so you can easily compare the testbed aspects. And we also are planning currently a new web seminar series for this year. It will start already next month, if I'm not mistaken. And it will present new white papers and also later in the year, starting in September, our current endorsed testbeds and their interim results, or if they have recently started, their scope. Next is also to bring industrial 5G closer to practice. I mean, we heard the challenges. One is education and the other is commercial availability. That's also then the third part here. But for information, our working group has prepared a white paper that's about to be published in 2 months' time on business value calculation. Here it's about having answering the question that many end users have, whether 5G is also something that gives them a financial benefit. And here end users will receive a guideline on how to calculate or how to estimate the business value of integrating 5G in their productions. Also, we want to extend education in terms of industrial 5G user guide. You have seen earlier there were some coming soon aspects on the website, and here extensions are planned for July and for September. And the last column demonstrating what's possible today to foster the commercially available ecosystem. We have the demo wall. Niels had a picture of it from last year's HMI and mentioned that it is continuously extended. We have also lots of interest here from 5G ACIA members, so it is continuously developed. Just want to highlight that again. So it makes sense to visit it once in a while. A next stop of the demo wall will be in the Industrial 5G Day in June in Helsinki. After that, in December, Industrial 5G Day in Tokyo, and then April 2026 Hanover Fair. Of course, and if there's any stop between that, you will get information via our 5G ACIA website. Also being extended frequently and is the industrial 5G device overview. We have seen that you can go to the website and filter very specifically by features of devices, and this is about to be extended also to devices that of companies that are not 5G ACIA members. So we are looking forward to have a huge extension here in 2025. And with that, I'd like to thank you for your interest in 5G ACIA, especially Working Group 5, and hand back to, I guess this time, Colin for moderation, right?
Not sure I'm qualified to be a moderator. Let me just finish things off. I believe Andreas was not able to join again. I have not seen him in the call. Yeah. So maybe I can just take the remaining time of 1 minute just to really thank everyone to be involved. So thank you for taking part. Thank you everyone for putting all this material together. I think it's clear this is the start of a journey, not the end of a journey, but I think this was an important step taking us forward. I think there's a lot of discussion, work, and hopefully a lot of collaboration going forward. And I hope that we'll develop these technologies so they're a solution for all of us. With that, thank you very much. And I would close the session there, I think, unless there's any other comments.
Thank you, everyone.
Bye-bye.
Thanks very much.
Thank you.
Thank you.